Okay, so we're now about to start a new chapter, which is on radicals and rational expressions. So we're going to start with section 7.1, which is on radicals, and it starts off with the idea of nth roots. So to start with an example, 5 squared is equal to 25, and negative 5 all squared is equal to 25. And so we say that 5 and negative 5 are square roots of 25. So you can see here that 25, the positive number 25, actually has 2 square roots. We can also look a little further at a different example, which is to say that 2 cubed is equal to 8, and negative 2 cubed equals negative 8. Notice that how here, because we're taking odd powers, that we don't have the situation where we have both the negative being cubed and the positive being cubed giving the same answer. The negative cubed and the positive cubed give 2 different answers, plus or minus 8. And so here we say that 2 is the cube root of 8, while negative 2 is the cube root of negative 8. And while we're at it, let's also make a note that it isn't possible to take an even power of a number and get a negative answer. And we'll get back to that in a little bit. So let's scroll down a little bit more and talk formally about the idea of an nth root, which is if a equals b to the n for positive integer n. And we saw previously that, for example, 5 squared, so b would be 5 and n would be the square. We also looked at cube, so n would be the cube. Then b is an nth root. Let me try to write that a bit more legibly. An nth root of a. And as we've talked about previously, if a equals b squared, b is a square root. Notice I didn't say the square root because there's 2, but a square root of a. And if a equals b cubed, b is a cube root of a. So going down a little further, this gets a little bit more complicated in the sense of if n is a positive even integer, so if n is even and a is positive, then there are 2 real nth roots of a. So looking at our example above, 5 and negative 5 are both square roots of 25. And you can have higher powers as well. 2 and negative 2 are 4th roots of positive 16. But the positive guy here, so notice that there's 2 square roots of 25 and 2 4th roots of 16. But we have a special name for the positive guy, which is the positive one is called the principal nth root. So 5 is the principal square root of 25, and 2 is the principal fourth root of 16. So that was when n was positive and even. We should also look at the case if n is positive and odd, n still being an integer. And the thing that's really interesting, because now it's odd, so we're taking cube roots or fifth roots or seventh roots. Instead of a being positive now, a can have any value. So a is a real number. Then there is only one real nth root of a. So doing our examples from before, 2 is a cube root. Of 8, while negative 2 is the cube root of negative 8.